boxed.
Okay.
This time it's 0, but it could be something else not yet boxed. If it has anywhere from 1 to 393 things, they would be things not yet boxed or can't be boxed because you don't have enough to fill up a box. Okay? All right. So that's an interesting relationship, and you might substitute a different adjective than interesting. Okay, I'm going to turn the page. So, anybody who was not here the other day when I passed out the division machine thing? So I need to pass it out. Keep your hands up, pass them around, bring the extras back to me. This was from the other day, if you got it here the other day, and if you weren't here the other day, you didn't get it. Everybody else got it? Pass them back. Thank you. All right. So we're going to first start talking about machine 1, okay? So on one side here, we have the division instructional sequence and task analysis. So you can see that there are only 9 steps, and only 2 of them are drill periods. The rest of them have everything to do with understanding. So you teach these other machines and these other instructional steps because it helps kids to understand what they're doing, okay? So the first step is called machine 1, and machine 1 is straight repeated subtractions of the divisor, okay? So if we look at a situation like this, and we tell a story, the story problem context has to be quotative. So I'm going to talk about Bob's Beetle Boxing Business, okay? And Bob's Beetle Boxing Business allows him to sell beetles in packages or boxes of 12,436. So in the beetle bin today, Bob has 41,362 beetles, and he has an order to fill some boxes. Let's see how many boxes he could fill today. Colleen, does he have enough to fill 1 box?
Yep.
He does. So he's going to fill that box, and now he has 28,926 beetles. Enough to fill a box?
Mm-hmm.
Yep. Fill a second box. Does he have enough left over to fill the third box?
Yep.
He does. Fills the third box. Does he have enough to fill the fourth box?
Nope.
No. So what did we do in terms of subtraction?
We continued subtracting from the original number until there wasn't enough
To
left.
fill a box.
Right.
Okay. So this is called straight repeated subtractions of the divisor. Where's the divisor? Colleen, where's the divisor? How can I change this from subtraction, repeated subtraction, to long division?
The divisor is the 12,436.
It is.
Right, you just put it right there. I was going to say.
Yeah. Do you see that this is exactly the same problem in terms of what we do, only we have to now keep track of how many boxes we have filled. What number goes right here?
1.
1. Does it go next to the top number or the bottom number?
Bottom number.
The bottom number, because that's 1 box of 12,436. I put another 1 here and another 1 here. What do those 3 ones have? What's the 3 in this problem?
3 sets of boxes of 12,436.
3 boxes. Is this the dividend, the divisor, the quotient, or the remainder? The 3.
That's the quotient.
It's the quotient. It's the answer. It is how many boxes we can fill using 12,436 as our boxing rule, how many we put in each box, okay? All right, and our remainder is 4,054. All right, so that's step 1 in the process. Step 2 in the process is to introduce what I just did. Actually, step 1 is only repeated subtraction, okay? So what's the name of that sign? It has a name. What's the name of that sign? It looks like a minus sign with earrings. Peyton, what is it? It's called an obolus, O-B-E-L-U-S. Did any of you look up that word that was your password for your
You told us that word the other
Turnitin.com?
day.
I figured it was something.
Yeah, sneaky, right? Yeah, I wanted you to be familiar with it before we talked about it in here. Okay? Some of you have musical training, yes? What does that mean, Gina? Repeat. Do you see right here that that's a divide sign, that's an obolus? Which means keep subtracting, repeated subtraction. Keep subtracting until you run out. Repeat. They're teaching math, they just didn't know it. Not really, I made it up. Okay? But my kids liked it. Those especially that musical background knew that when you put earrings on your subtraction sign, it means to keep subtracting, okay? And so this is adding, and mathematicians who are lazy just keep adding the same number over and over and over again. See, they're lazy, lying down now instead of standing up. And then we subtract, and then we keep subtracting. New understandings. Totally bogus. If it works. Okay. So we've introduced that. This. Yes, question.
Yeah, I just have a quick question. So we had 3 boxes, and the last one, then the remainder. Would you want us to put that at the end, or is it just fine showing the steps?
It's fine where it is. If you as a teacher want them to learn to put it up on the top line, what's the name of the top line? What's the name of that line? How do you know where to tell them to put it? What do you call it? What do you call it? Anybody? On top.
Remainder bar.
The remainder bar. I like that. What bar do you go to? The remainder bar. It's called a vinculum. V-I-N-C-U-L-U-M. Will anybody ever ask you that in the whole world? Probably not. Okay? But what's so interesting is these 2 horizontal bars are both vinculums. Would be vincula if you like Latin. That would be plural for the neuter. But in any case, 4/7 is the same as 4/7. 4 divided by 7. What? Vincula? Okay. Did you ever take Latin?
No.
No. I not only took Latin, it took me. Yeah. And my mother was a former Latin teacher, so she insisted that I take Latin. And all I remember is ara, vexed, acine, cum, pro, pre, and sometimes sub and supra are the Latin prepositions that take the ablative case. Nobody's ever asked me that. That and hic, hi, co, huyus, huek, honk, co, horm, hias, horm, he, sai, ho, ha, si, whatever. There are 30 different versions of this and these in Latin, and you have to know nominative, genitive, dative, accusative, ablative, singular, and plural. I know. What?
No wonder that language died out.
I know. It was never a spoken language. It was only a written language. Italian is based on it, but not the same as. But in any case, Caesar spoke it. You know, vidi, vidi, vici. I came, I saw, I conquered. Yeah. You say vici? My Latin teacher said vici. I don't know. And he was a former Latin teacher at the Catholic high school, and he walked around with a big meter stick. And as you started to answer questions, he started hitting you on the back of the neck with the meter stick. The longer you took to answer, the harder the hits were. This was back before it was illegal to hit your children. They used to do it a lot.
Good old days.
The old days. Do you know what rule of thumb means?
A stick smaller than your
You can't get
thumb.
a stick that's thicker than your thumb.
Yeah, if you're hitting your wife with a stick thicker than your thumb, it's against the law. If it's less than the thickness of your thumb, it's okay, according to the old law. Honestly, that's what a rule of thumb is. We don't like that definition, do we? No, but that's where it came from. That's its denotative history.
What if you cut off your thumb?
Whoa,
Until
you couldn't get your
one of
wife.
them nuns.
What if she cut off your thumb? Okay, enough fun.
As long as it's not.
All right,
Like Jane. I've really heard
so,
things like erasers, like your
Super
markers.
thought never had a wife.
Hit. Not with a ruler in there. No.
so what is the label for the 58 and what is the story problem for the 58? Corey?
I have 239 things, and I want to see how many people can get 58.
I don't know what the label of 58 is yet, that's what we're trying to
Oh.
find out.
Things.
Things,
Yeah.
yeah, in order to be quotative, these have to have the same label. So I have 239 things, I want to give 58 things to as many friends as I can. How many friends can I give things to? Solve this problem using machine 1, which is repeated subtractions of the divisor.
Am I doing this, or is this individual?
Right now, everybody's doing it on paper. Thank you for asking, Corey. Sometimes it's ambiguous, isn't it?
Yeah.
Ambiguity is a real problem when you're teaching, and you will find out over and over and over again, clarity matters, and thank you for pointing that out. So what can you say about the problem that Corey gave? Jenny, it must be your day.
What would you like me to say about
I
it?
would like you to explain, not step by step, but just overall. She asked if I had 239 things and I wanted to give 58 things to as many friends as I could, how many friends could I give 258 things to?
4.
4. Will I have any things left over?
You'll have 7 things.
7. How would I find 239 with 4, 58, and 7? What do I do with those numbers to come up with this number again?
I don't know.
Okay? So I'm going to talk to you right now about a move that you will often need to make in your classrooms. It's called the simplify the numbers move, okay? So if I had this problem, what's my quotient and what's my remainder?
4 remainder 2.
Exactly. Now, how can I get a 14 if I don't know that I want a 14 there? Where do I get the 14 from? Because I can do it with those numbers. How?
3 times 4 and then add 2.
3 times 4 and add 2. So if you multiply the quotient times the divisor and add the remainder, will you always get the dividend?
Yes.
Yes, you will. Please do that here.
Wait, what?
It's okay. Ask your question again. Wait, what means what?
Do that again.
Yes. So if we did not know the dividend, could you from this produce it?
Yeah. 'cause you know
How?
3 times 4 plus 2.
Yes, and that's 14. We did something here, and I asked if we didn't know 239 things,
So we do
could we find that?
4 times 58 plus 7.
Absolutely. Okay? And so that was what I was trying to get Jenny to come up with, and no, it's fine. What I just want to point out to you was the move that I made, which was to support her thinking by making it something where the numbers